Look at from electronics perspective, there are some other strategic areas where the electronics manufacturing into the own country is very important. Then looking at even the example like a CCTV. And that's because of CCTV, the issue is coming up about the cybersecurity. Whether somebody is reportedly monitoring everything and they are controlling and they know what's happening. So if you have your own manufacturing, your own standards, that means you are able to manage the cybersecurity related requirements as well. Typically what we have seen is one job in the semiconductor industry is creating 10 jobs in the other industries. Almost no significant phone manufacturing by Apple in India to 15 to 20 million units being made actually. It's a highly significant milestone. So India need not replicate what China did 3 decades ago. We should reinvent and relook and innovate for a different business model. The brand-related profits, those are made, would be retained in the country. That's the economic value which you create and you harness. For high-end phones, which we refer, let's say S25 Galaxy, for example, or iPhone Plus and all those, surprisingly, for the viewers, the bill of material cost could be less than 25%. And this is where the economic value gets defined.
Hello and welcome to the Escape Velocity podcast by Outlook Business, where we talk to the movers, shakers, thinkers and doers of the tech and startup ecosystem. Today we have with us Mr. Ashok Chandak, the President of India Electronics and Semiconductor Association. Hello Ashok, how are you?
Hi, thank you very much. I am good.
So Ashok, today we want to talk about the electronics and semiconductor industry.
Sure.
And the thing that makes me most curious is today all countries in the world are racing to insource the electronics and semiconductor ecosystem within their countries. In a way, every country wants to become Atmanirbhar in electronics and semiconductors. Last year, Indonesia had banned the iPhone 16, saying that it does not create enough value addition within the country in its manufacturing. Just a few weeks back, Donald Trump threatened Apple and told Tim Cook that he must not manufacture iPhones in India, but in the US. So why is it that every country wants to bring this electronics and semiconductor ecosystem within their shores?
Very valid point actually, and that is the trend we see now over last few years, where most of the global companies, if you look back few decades ago, there were focus on a technology development and the manufacturing was outsourced. So that is where the countries such as Malaysia initially, followed by China, Vietnam, then Taiwan, they came up as a manufacturing activity of the electronic goods and semiconductor goods, while some of the global companies retained the ownership and competence on the technology and IP creations. Over the period of time, things are beginning to change. And this is what you see, as you narrated already, that the several countries are now looking at inshoring, so-called, or I would call getting the manufacturing into their home or a backyard. Few things. One is, and which is most important, it is realized now that the electronics semiconductor are a foundational technology. So they enable everything. The way mankind and the world is moving now is highly dependent and influenced by these technologies of semiconductor and electronics. And during COVID era, that was the first time when everybody realized that the supply chain was so complex and it really started to create some kind of difficulties. In addition to that, there has been now geopolitical situations and some of the war-like situations where again it's realized an increasing importance of the strategic nature of these technologies to be manufactured into the own country so that you have it when you need it. But beyond that, actually, there are also several other reasons, and particularly one of the reason is the economic factor. The global electronic industry is already running trillions of dollars in terms of the market size. And the semiconductor manufacturing is about $565 billion last year. It's huge. And that is the economic topic in terms of the industrial activity which is also then relates to the employment generation, the IP development, the prosperity of the country, the import-export trade balance. All those things are related to this. And this is where now the countries have started to realize that it is good to have this electronics and semiconductor manufacturing into own country, so that you create those employment, you create the economic value, you retain the economic value. And I will give you an example how it works still today. The most of the products, those are made. The margins are not in the manufacturing activity, core manufacturing activity. The value addition from manufacturing is limited. So for example, you referred the iPhone today, for example, or let's say laptop. So the overall bill of material or the component cost is one element. The IPR, design, software, branding is another big chunk of the value addition. The manufacturing piece is a very small. So pure play manufacturing value addition is about 8 to 10% only.
Okay.
That's too small. But because of this other consideration, what I have narrated, it is important that to some extent, the manufacturing activity is retained in a particular country. And now looking at countries like India or let's say US, for example, you took example of Mr. Trump and I will bring the example of India. I mean, we have such a big demography and about 1.4 billion population in the country, and the demand for electronics and semiconductors keeps increasing. We cannot be dependent on the imports perpetually. So India has a plan to do the manufacturing in India. US, they realize now 50% of the global semiconductor brands are US brands, US companies. Be it NVIDIA, be it Intel or AMD, Texas Instrument, and you keep counting. But the manufacturing activity is limited. So all these companies, they do outsourcing, they manufacture into other countries and ship. So the realization is if this all manufacturing is in own country, that adds to the economic value. It adds to the self-sufficiency. You have the parts whenever you need it in case of emergencies. This enables everything, be it automotive, be it healthcare, be it the personal gadgets, be it the computing systems, be it the AI data servers and everything. These are all enabled by electronics and semiconductor. So you need to retain the control point for not only the IP developments, but also manufacturing footprint. And that's what you see now, that the world is looking at getting back as much as electronics manufacturing into their own country.
I want to understand this, that you said that 8 to 10% is in manufacturing. So you mean it's the assembling part?
Yes, absolutely.
Right?
Absolutely.
So can you help break down for our viewers, let's say in a smartphone, in the bill of materials, the cost of making that phone, what percentage is, the components, and what percentage is assembling, and what percentage is the design and branding and everything?
So look at the classic case, and now you have to look at two different ends of the phones, because as you took a phone. So one's the most premium phone today, let's say Samsung Galaxy or Apple iPhone. And the another end, you have to look at the low-cost phones, which are sold, let's say, from Indian currency perspective, less than 10,000 smartphones, 5G, let's say $100, other thing, two extreme things. And why I took this example is because the bill of material percentage of the total phone selling price in the market differs now based on the brand names and other things. So for low-end phones or normal branded phones, including, let's say, examples of Oppo, Vivo, or OnePlus, or Indian companies like Lava or some other people, the overall bill of material cost could be in the range of about 50 to 60%. Bill of material means all the components, including PCBs, the semiconductors and displays and other stuff. Plus you have the IPs, the softwares and other stuff. Then you have the branding cost and your profit. That's how it works. For high-end phones, which we refer, let's say S25 Galaxy, for example, or iPhone Plus and all those, there, surprisingly, for the viewers, the bill of material cost could be less than 25%. So and this is where the economic value gets defined, that you have all the components, everything is just less than 25% of the final retail price of the phone. The rest of the stuff is the innovation related money and R&D spend what company does. They create the highly reliable and a very high performance product. There is a good user interface and a brand name value. So that's how it goes actually. And that would explain now that if somebody looks into the balance sheet and the profitability of the companies like iPhone maker, they generate billions and billions of dollars, which is sitting into the cash somewhere actually. This is the reason why you see the profit margins are very high for the brand name.
Also, I want to understand then that if the bill of materials is as low as 25% and then add another 10% for, let's say, assembling, that it is maybe 35 or 40%
Yeah, less than 35 for a high-end phones.
for a high-end phone, which is the whole manufacturing component of it. The US has all the big brands. US already has 60% of the value of that phone. It is still looking for the 35%, the other 35%. Why?
See, in that remaining 35% also, what to realize now, when you start to make a phone is the example you are taken, but any electronic products, it has got hundreds of other components sitting onto the PCB. We call a printed circuit board, which is parts are sitting over there. The moment you enable the manufacturing of a phone in a country or a laptop or a healthcare equipment or a car electronics board, you are expecting that it creates not only the employment for manufacturing, setting up the plants and machineries, use of the electricity and water and anything, whatever you require, plus also enables the additional industry. So while making phone now, some countries were importing everything, and India is another classic example. When we started phone manufacturing just 2-3 years ago, we were importing 90% of the components. Now, once the phone gets manufactured, the local ecosystem flourishes. So most of the components would finally get manufactured locally. So that expands the industry. It creates employment, it generates taxes, it generates money. So these are the reasons actually. And then you have a control. And now you are taking an example only phone. But look at from electronics perspective, there are some other strategic areas where the electronics manufacturing into the own country is very important. Be it a defense-related topics, the radar-related topic, the telecom infrastructure. Then looking at even the example like a CCTV, which is a very simple example and everywhere it is used, roads or houses and everywhere. Now, if you are having, and that's because of CCTV, the issue is coming up about the cybersecurity. Whether somebody is reportedly monitoring everything and they are controlling and they know what's happening. So if you have your own manufacturing, your own standards, that means you are able to manage the cyber security related requirements as well. Then the automotive vehicles, for example, the healthcare related topics. Typically what we have seen is one job in a semiconductor industry is creating 10 jobs in the other industries. So component ecosystem, the logistic ecosystem, the supply chain ecosystem, the import, export, and various other things. So we have to look from that perspective actually, that this is the big enabler for additional manufacturing footprint, the financial activity, as well as the jobs. And a country like India, it's very important. In US also it is becoming important because at one point of time, US was one of the major manufacturer of the goods, while unemployment rate there has also gone up, and in that country unemployment is a big question.
I also understood that recently there has been a report that Apple's manufacturing in India of iPhones, the value addition, the local value addition in it has risen from 8 to 10% to around 20%. So I want to understand how significant is that?
Sure. No, it's
and
a very
how
valid
much
point.
more can it grow?
No, it's a very valid point. And I would call it's a highly significant milestone. Now, whether it's 20 or 18 or 22 doesn't matter much actually. What is important here is from almost no significant phone manufacturing by Apple in India by 2017 or 18 time frame compared to 15 to 20 billion units, million units being made actually. And on a value addition, typically value addition means what? Value addition is basically the amount of local sourcing which is done, the components, the plastics, materials, mechanical screws, PCBs, whatever, components, electronics, semiconductor, display, whatever is utilized, which is a locally manufactured into that particular device. And phone is the example you have taken actually. And same thing can be related to other electronic products because it's just a representative purpose. So this 20% or beyond is highly significant because this indicates multiple things now. Number one, it indicates that India is rising to become a global manufacturing hub. India is creating a trustworthiness to the global markets as well as the Indian companies that we are highly reliable country in terms of the manufacturing excellence, in terms of increasing the additional number of components opportunities for the country. And this has to go up, surely. Today, look at the same iPhone, what you are referring. The reports indicates that in China, the value addition has been to the extent of 55 to 60%, which is significant actually. So can India reach that? May not be same level immediately, but we are on the roadmap towards increasing the value addition. Now, both industry and the government are playing a very important part and a role into these value addition norms. Number one, there's an increased focus on increasing the value addition in all electronics manufacturing. So our body like SEMI India as well as India Electronics Semi Association has been talking about it almost a decade now. What is the importance of value addition and how it could be done, and it is progressing. So we used to be like less than 10% value addition about 5-7 years ago. We were about 18% on average value addition by last year. And we have a roadmap now along with the mighty Ministry of Electronics and IT, which is really helping out on this to reach about 35-40% value addition in 5 years time frame. That's overall across the country we are referring. And multiple steps have been taken accordingly with regards to some of the schemes such as production link incentive, the design link incentive, the electronic component manufacturing ecosystem related portion. Plus, the various state governments are also rising to the occasion and showing high degree of interest and support. So you would see Gujarat has done incredible work in supporting the semiconductor ecosystem by incentives and policies, the water, electricity and infrastructure, building everything. Karnataka has shown a very good support with regards to the innovation and the design piece. So a lot of semiconductor electronic design are happening into the Karnataka now. Look at Tamil Nadu, the electronics manufacturing, they have stepped up all the policy supports and the labor related topics actually. So electronics manufacturing is a very high stage in Tamil Nadu and still growing. Other states are coming up. So there is a policy in Assam now. Madhya Pradesh is talking about. Andhra Pradesh under a new regime of Mr. Naidu is making efforts. Maharashtra has something already going. So many states, the why I want to bring example is many states are coming forward now, putting up the policies, incentives, infrastructure in place, fully knowing that there is a good need of these things to expand the industry. Last year, India made about $150 billion worth of electronic goods, which is sizable. Currently, we are working along with the PMO and also MITI as an ambition. I think our Honorable Prime Minister, Mr. Modi, already have spelled out, including the Union Minister, Mr. Vaishnav, that we should look for about $500 billion worth of semiconductor and electronics industry size. We call ESDM, Electronic System Design and Manufacturing Market. And we are trending that. And if we are to reach that stage, that means this value addition has to also grow up. And there are various schemes, those are going to help out actually on this. The value addition will go certainly. And a particular product, what you refer, I can indicate that today we are, let's say, 20%. It could grow in next 2 to 3 years, 30% plus. Today they do, let's say, manufacturing or assembly activity. Some of the plastics, mechanical screws also, even a press fit, something is going on. Very soon you would see the PCBs, those will be made here. Then you are looking at the display assemblies, display driver ICs, for example. HCL and Foxconn is setting up a plant in Uttar Pradesh to do these display driver ICs that would get insourced for manufacturing. There are a lot of semiconductor OSATs ramping up. They would assemble the products. So slowly this is going up actually. And my expectation is, except maybe some of the leading edge node high-tech semiconductors, those are using 3 nanometer, for example, from Qualcomm or Apple or memory components, for example. They may still get import, but it's not too far that we are reaching about 40-50% kind of a value addition for electronics manufacturing in about 5 to 7 years' time. And not only this product, but the various other products.
So China's rapid growth in the electronics manufacturing sector has been a lot because of how the government has created these restrictive labor policies there, where their freedoms are curbed, they are not allowed to protest. And that's why the big electronics manufacturers have found a great home in China. Do you think that model is replicable elsewhere in the world, especially in democratic societies like India?
So I would say the all these business models and a way of working is also a function of time. Whatever is relevant 3 decades ago may not be necessarily relevant today. Number two, we should look at what is the end goal and objective. It's like a mathematics. You could solve the puzzle by multiple formulas and reach the outcome. So a similar thing here as well. There could be different ways of implementation and execution of the policies with the end game or the end goal of flourishing the manufacturing activity. So India need not replicate what China did 3 decades ago. Then we are just following. We should reinvent and relook and innovate for a different business model while achieving the similar objectives. And that is what India is doing actually right now. So, yes, at one point of time, India had labor troubles. We used to see labor unions and lockouts in many industries few decades ago, but these have already gone down substantially. Not question of electronics, but even other sectors. Things have changed.
Recently, something like that also happened in Tamil Nadu, right, with Samsung, where
but these are just the few cases those are coming up now, which used to be a much frequent couple of decades ago in India or even a decade ago in multiple sectors, not only electronics, but multiple sectors. And I know we have seen the issue when Nokia used to make the manufacturing in Chennai, near Chennai in Tamil Nadu. On one point of time, it was a big setup there and suddenly started getting into troubles later on. So now what we should look at is how we can use our strength, which is more of a democracy-related topics actually, to achieve the objectives. And that's what India is looking at. And for India, the complication is also the center-state equation. The states were at one point of time looking at this is a central government policy. Now, no more. Some of the states are realizing that it's the center and state together working on a particular vertical and a sector is much more useful now. And that is what is happening. There are some centrally defined policy initiatives, the incentive mechanisms, and there are state level infrastructure creation readiness and other policies that would complement to get implementation done. Finally, everybody has realized it is at the state level where the activity would happen. Any state for that matter, because you have to create a manufacturing facility, you need a land and you need infrastructure, you need logistics, you need communication. All those things are required at the state level. So now India is working on this model, which is working quite well actually, because we have seen last few years, both semiconductor and electronics manufacturing footprint is growing with the center-state combo working. And there are multiple policy initiatives. Our policy today framework is looking at a winning trio, what I call winning trio. Because for any electronics manufacturing, there are a few things required actually. So one is now here, there are government policy framework, which is Semicon India program that enables the semiconductor manufacturing in the country required for the electronics manufacturing. Number two, electronic component manufacturing ecosystem. There are a lot of electronic components required, resistor, capacitor, passives, inductors, PCBs, display modules, assemblies, all those things. There is a policy now, which is there. And third is about central and state related topics. These are all helping together to stitch a very holistic approach of a competitive electronics manufacturing activity. And we have seen that there are several EMS companies, those who have grown leaps and bounds in terms of the total manufacturing what they do. Example is Dixon Technologies, Keynes, from South India. Then there is a Sirma SGS, and there are global companies also setting up their operations here, like Foxconn, Flextronics, Sanmina SCI, Jabil, and others. So all these things are really um, contributing in a holistic way to enable a sustainable and a competitive manufacturing activity. And this is where I am saying that we don't have to replicate the China model, but we have to look at it in a different way ourselves with the current requirement and the situation to enable this kind of stuff. There is a talk about China plus one, because also many global countries have realized that they cannot be dependent only on one country actually. So I would say it is not question of China plus one. India is playing a card today and working on a strategy which is not only our own consumption related manufacturing, but also India for many. So we are looking at multiple countries for exporting the manufactured products. That gives us the economics of scale. And India itself is a big consumption actually, considering our population and need of electronics. So there is a huge demand in India, and which is something different from other Asian countries, be it Vietnam, be it Thailand or Malaysia or even Singapore. These are the countries, those were doing a lot of electronics manufacturing before. They still continue to do to some extent, but they don't have their local demand actually. So this is what India is leveraging now, that we consume for our India needs as well. And in the process, we also build the reliable supply chain and a quality manufacturing footprint, which is utilized for global demand servicing.
Another question I have is, you just talked about the trio strategy, of which one part is design. Now I want to understand, if we talk about semiconductors, the biggest semiconductor design company in the world today is NVIDIA. It's the hottest stock in the market. It's worth $3 trillion. And NVIDIA says that 80% of their chip design engineers are in India. We have seen data that 20 to 25% of the world's chip designers are in India. So we have Indian chip designers designing all these advanced chips from India, sitting in Bangalore or Pune. And its country is like the US, companies in the US or Europe reaping the benefits. Why don't we have those kind of companies here in India?
Yeah, it's a very valid and very good question actually. And that's really a curiosity for many people. The point is, we have to go back a few decades. And some of these global companies, what we are referring in the field of semiconductor now, have not come up overnight. They have been there for 3 decades, 4 decades, 5 decades. Some of the companies, for example, Philips Semiconductor, which is NXP now, was founded in 1951. Look at the Texas Instrument or Intel, they were founded about 4 or 5 decades ago. So, India policy, the strategy and approach during 70s, 80s was not related to this sector actually. We did not invest. We did not have right policies. The Indian corporates were busy in core sector, textile, automobile, the metals manufacturing and other stuff. This were there. Then when the next revolution came during 90s and 2000s actually, India chose to deploy our talent, because again led by many companies, a path of least resistance in terms of the called as the services business. So we became the software developers, IT services, the design services, deploy the headcount, 1 lakh rupees salary, you bill 1.2 lakhs, 1.3 lakhs to the end customer and continue. That's a business model, became highly successful. Nothing wrong in that, because at that point of time, that was the situation, and it has created a good base of the Indian IT software developers as well as the design ecosystem players. So this is where we have achieved the good strength and a supremacy. But in the process, what we missed out is a product creation. So Indian companies did not focus and did not spend much efforts on product creation and creating of brands. And it takes decades and decades. So some of the example which we have taken, for example, Apple or let's say Dell or some of the automotive makers in Germany, for example, like Mercedes or BMW or General Motors, or healthcare providers like Siemens or GE, they focused on creating their own brand value and a product creations basically, which India did not do. Indian companies did not do. It takes time. It needs a lot of investment. And sorry to say this, but even a decade ago, 5 years ago, most of the Indian corporates, any sector, their investment in R&D was quite limited. There were some government policies which were pushing and compelling them to put investment in R&D they were doing. But the amount of investment which was flowed back from their manufacturing operations in R&D was quite limited. And all these technology sectors, high-tech sector needs a humongous R&D activity. Most of the chip companies spend about 15% to 17% of their manufacturing activity into R&D activity for product creations and R&D. So this is what we have missed out. And this is now reflecting that we do not have those product companies or brands. Not only semiconductor, but even I tell you electronic story. I remember during my childhood days, we had a lot of electronics brands. So there was a Videocon, there was a Onida, there was a Crown, even the Godrej was doing a lot of activities and few more. Many Indian brands disappeared now. So today you go into the market and buy a color television, whether it's a LED television, QLED or whatever technology you call. Where are the Indian names?
There was recently this viral social media post which said that the Indian brands of the 80s or the 70s, they were so good that they lasted so long that people did not want to buy, another
Replacement.
device.
Yeah, replacement.
There was no replacement, and hence those companies died. Do you kind of think that
No, that is not
reason,
the
or is
case
it just
actually. No,
yeah.
that's not the case. The
Yeah.
things have also changed actually.
Yeah.
See, I remember the first phone when I brought 1995 Motorola Star Trek. I used 5-7 years. Same thing you might have seen with your parents and senior people actually. Things have changed. Now technology is changing so fast and these all product categories are changing so fast that people are replacing them more frequently. And you're right, the CRT TV which somebody has brought 21 inch or 29 inch was a bigger size, let's say, they kept it for 10 years and it was working. Now the current televisions and other things also people can use it, but in 3 to 4 years they will change. Because something better has come, some better functionality and all those things. So things are changing because of the technology movement there. That's what is changing over there. So coming to the original point, this is where the difference has been. Now again, there is a focus, and this is what we have also recommended multiple times to Ministry of Electronics IT, that India need to create a focus on product creation. So India should become 3 things we are referring right now, and that's a strategy and a vision which we are driving as an industry body. India is a product nation. India is a production nation. So that's a manufacturing topic we are referring. And India is a skilling bank, skilled, talented people. And that we already have to large extent, and we can still build on that. The product creation is important, and I go back to the first question you were asking in terms of the various companies and a value addition I have narrated and told you for the benefit of users and audience here, that there is a tremendous value in the brand and the IPR what you create. And that is what when you own your own product. And that is economic value retained in any country. So today, if we are able to create good brands, for example, you referred the case of Apple, just an example, or Samsung. If we create similar brands in India, the brand-related profits, those are made, would be retained in the country. That's economic value, which you create and you harness. So India need to get to that level. And there are new schemes being launched by Ministry of Electronics and IT for our segment and vertical, called the Design Link Incentive, then the startup programs. These are now being targeted to build India's own products. So complete end-to-end definition, design, manufacturing, and a productization and a branding. This is what we are progressing now. It may take decades before we reach that critical mass where some of the other countries, particularly you referred example of the European as well as the American companies, and again I can add into that the Japanese companies, for example. They have a very solid brands, and it will take time for us, but I think we're moving in that direction to create our own brands and our own product creation. So this is where it has to go, and that should be the focus going forward for the country.
When we talk about electronics manufacturing,
Yeah.
phones have become very big. I mean, Apple is producing here, Samsung is producing here. What I want to understand is today India also has other aspirations. We have aspirations like making a fighter jet locally. We also want to make the EV transition and have big companies like Tesla produce here. We want to grow our own domestic companies to be maybe as big as BYD in China. So I want to understand that the phone ecosystem that has developed today and the component manufacturers who are coming up. So does this have an effect on the other adjacent systems, ecosystems that want to come up, that we want to develop? So is there an overlap, or we are kind of talking about building everything from scratch when we are talking about building jets in India or building EVs?
Very good question, actually. And this is very pertinent also because many times it is seen that the products what you narrated and mentioned, these are a different functionality. They need a different expertise. They do a different function. They serve different market segments. So the question naturally comes whether we are going to create for that particular segment or product category everything from scratch. And the answer is no. There is a lot of reuse. And I think it's like a kitchen. I don't know whether you have worked in the kitchen or not. Or I remember now, maybe first time I went to hotel was about 25, 30 years ago. And when I go and ask this guy, he said, sir, I asked him, what is the menu? He said, sir, I can get you aloo gobi, I can give you aloo matar, I can give you aloo paneer, I can give you aloo palak, I can give. He went on. I was thinking, do they have all these 15 vegetables cooked and ready? I went inside to check it out actually, and nothing was ready actually there. So what they do is, they have the basic ingredients available, and depending on need, you make a recipe and cook and give it. Same thing we do in the kitchen also today. So our, not exactly the same, but our industry is in a similar levels. It's a layered approach. So there are some of the topics, materials for example, many materials are common for various industries. Then some of the components, let's say printed circuit boards, the passive components, the manufacturing setup is the same. You produce at a different rating. So you may need, for example, for a phone, the parts those are operating at 2.3, 3.3 volts, very, very low power consumption. You may need, same thing when you go into the automotive or car electronics, you said EV. You may need some of the parts to operate at 12 volts operating voltage or 24 volts operating voltage. And you go into the defense related topics now, you may need to operate them at a 48 volts or even 110 volts. You go to the household appliances, you have 230 volt power supply. So, things are looking to be a bit different, but you will make these components manufacturing, which is utilizable across multiple verticals and multiple domains. Same is going to happen for semiconductors as well. So you may have technologies which is, let's say, leading edge and a lagging edge node, and both I will explain, where you will have 90 or 120 nanometer manufacturing technology. By the same plant, you will be able to produce the semiconductors or integrated circuits for, let's say, power management IC of a phone, or some of the components which are required for automotive electronics, or some components required for a jet. Maybe for a jet, then same component you have to do radiation hardening, or military grade packaging. That's a last step. But the basic design, you could do with a similar. Then the tools what you use are again common. The EDA tools which are required to design the chip, semiconductors, or the tools required to design the other electronic components are again common. So there are various commonalities that does exist, which you can rebuild. The very classical example recently what I have seen is called the thermal management. Because when you design any electronic product, as you are packing a lot of functionality inside and you are running a CPU at a very high speed, be it a phone or a laptop, for example, CPUs are running at 2.7 or 3.3 or 5 gigahertz as the speed. The faster they run, they consume more power and it heats up. So you have to do the thermal management so that it doesn't heat up. And you would have seen some phones they will hit, some phones don't heat up actually, because they manage the thermal inside properly. Similar thing happens on the laptops. So this thermal management learnings from such products could also be applied into electric vehicle, could be applied into the defense related infrastructure, could be applied into the healthcare gadgets, the industrial automations, all IoTs. So there are several commonalities, and that's why I said it's a layered approach. Obviously, everything you cannot use as it is, but you have to make some modification, adaptations, depending on the use case. But the final answer and summary is it is not necessary to create everything from scratch and an independent compartment for each product type. No. There will be reuse, there will be platform approach, and there will be some adaptation which we'll do at a last stage to fine-tune it for a respective application. And that is a beauty and that is a strength what we have. That you start building the ecosystem for semiconductor, you can use it for variety of domains, including the defense or let's say personal gadgets. You build the electronic component ecosystem, you can use for everything. You build the material ecosystem. For example, now there is a critical materials or minerals is an issue. China has blocked and many countries are in trouble. So India is also looking at too, because we have a lot of rare earth materials. We are not processed, but so we start doing that and we can use it across multiple of segments. It could work.
Another thing is that you talked about how a lot of states in India today are looking to manufacture electronics and semiconductors. Everybody is attracting these companies with additional incentives on top of what the center has given. Now, I want to understand, when we are paying so much money to these companies to create these, build these plants in India, why shouldn't we get the most advanced technology? Let's say in semiconductors, 3 nanometer today or maybe 2 nanometers, that's the most advanced technology.
Sure.
Whereas we are paying today for technologies which are a few generations older. So it's like I am paying a lot of money to get an older iPhone or an older version of a Samsung phone which is 5 years or 10 years old. Why is the government doing that? Can you also explain this leading edge and trailing edge difference?
Again, it's I would call a wrong optics actually from the audience and people perspective. And it is also wrongly narrated in the public circle. I will give you an example. So leading edge and lagging edge, what you mentioned, for electronics related stuff, which you need the semiconductors, and for semiconductor manufacturing, the commonly used word is what is the technology node at which you do it, which is basically the thickness of any transistor design, what you do on a silicon wafer. And the smaller the geometry, smaller the size, you are able to pack more number of pieces. So initially, let's say during 1980s, we used to pack about 100,000 transistor on a single chip, which has gone now to the billions and billions of pieces because you make it smaller size, smaller one. And that's called as a leading edge or a latest technology of 2 nanometer, 3 nanometer, or below 10 nanometers, let's say today, leading edge. Rest of the stuff is called lagging edge. Initially, when this semiconductor development started, it used to be 350 nanometer, became 180, 120, 90, became 65, 45, 28, 14, it's there. Now, if you look at the total market size of semiconductors, which was $650 billion now in the previous last year, 40% of that was on a lagging edge and 60% is a leading edge. Now, by 2030, it is expected that the semiconductor market globally would exceed $1 trillion. By that time, 70% would remain a leading edge, 30% would be lagging edge. That means there would be $300 billion worth of semiconductor requirement in 2030 from the lagging edge technologies, which we can call as a 28, 45, 90 and so forth. And today, it is in the similar percentage level I said is about 40%. So demand still exists. See, these leading edge technologies are not necessarily used for everything. You will use leading edge predominantly where? Data server, AI servers, the smartphones, couple of components there mainly. The main CPU is where you use that. Then the laptop computers use the microprocessors, that CPUs. You call, for example, Intel i12, i13. So very commonly used word, or similarly from AMD actually. And memories. So they are using the leading edge technologies. So we should not be looking that we are paying for old generation technologies. We are paying because demand still exists. And these components are required for every other electronic products. Be it healthcare, be it industrial automation, is IoT, even in a smartphone and a laptop. There are several components. Those are on a lagging edge technology actually. For example, the RF part, the power management ICs, the power dissipation ICs, the power adapters, for example, what we use actually, including some of the display drivers. So these are still used 14, 28 nanometer kind of a technology nodes.
But the demand for these will go on decreasing, right? Like you said, it's 40% now.
Sure.
5 years down the line, it's 30%.
Sure. But what is the market size that time? Still $300 billion.
Yes.
It is not small. Today, out of 650, the 40% is what? Still $250 billion. So market is not decreasing. I'm coming to that. Lagging edge would be required. But first thing we need to clear from the mind of the people that this lagging edge, old technology, we are wasting money. No, we're not wasting money. It is still required. It will continue to be required over decades and decades, actually, still more. Because there are several components which are done. These are being manufactured at the technology node, which is so-called the lagging edge. I mentioned 28, 45, 65 and all those. Particularly for most of the automotive components today, except one or two components are on a lagging edge. Most of the industrial automation are on the lagging edge. Particularly our power management, power devices actually are on a lagging edge. So we are not wasting money. These are required and this will continue to be required. Now, should India invest and get the leading edge? Yes, we should do that because from a futuristic perspective, it is required. But also we need to be aware that to set up those plants, we are at a major disadvantaged position. First thing is we don't have our own companies having any process or a technology or a know-how to make those things in India. So we are fully dependent on some of the global companies to come to India and set up those leading edge technology terms. And they are not willing to transfer the technology because it is so specialized and it is held by a handful of companies. So they are not willing to transfer the technology know-how so easily for 2 or 3 nanometer in terms of the manufacturing process. Design is a different topic. India is already there. There are a lot of Indian companies, global guys, including Indian startups, working onto the leading edge node for a design activity, including design outsourcing. But on a manufacturing is a different ballgame. And that is where we don't have process know-how and the global companies are definitely not willing to transfer the technology for a leading edge node, as there are very few companies hold that IPRs actually. So we are at a disadvantage. Number two, the manufacturing cost of setting up the foundry or fab for leading edge runs into huge cost. It goes 8 billion, 10 billion, $15 billion for a single plant. It's a big chunk of money. In that money, we can still utilize and target this existing technologies which are still required for majority of the equipments and products and would be required several years in future. So that's where, India has position that whatever could be done when available funds, those were made available as incentives and subsidies, whatever projects came up, the companies came forward, they start to invest. And look at now the situation. We know that the big corporates like Tata, then the South India Murugappa Group through their company called CG Power or Keynes Technology, now HCL joining hand with Foxconn, they are also getting into this manufacturing activity and they understand very well. So they also have a desire and ambition to do leading edge, but there are limitations actually. We have to be aware. So it will happen someday. I'm not saying it won't happen. But my only point here, I'm to guarantee, if we are not done leading edge immediately, we are done lagging edge, nothing wrong. I think strategically it is good. Actually, I would support that. Target is good. Available funds were used for multiple things. Today, there are almost 6 projects approved by central government for the funding. And there are another 6 projects I am aware of where state governments are funding. Central government fund is not approved yet because of the limitation of the total corpus that was available. But there are 6 projects approved by multiple state governments, and they are giving the subsidies, be it in Orissa, be it in Gujarat, be it in Maharashtra, be it in Assam. So it's already progressing. So we should just judiciously use this available funding to get started somewhere, because India has been far behind in the semiconductor manufacturing curve, and that's what is progressing. And as this progresses, establishes its own our credibility and competence and trustworthiness, I'm sure there would be opportunities for a leading edge manufacturing in future.
Intel had a few years before restarted its own foundry business. I think it used to exist. Then the foundry business for some time was not there, and they restarted it, I think, a few years back, right?
Yeah.
And now again they are thinking of kind of either hiving off or selling the foundry business. And the reports around that were that they were not being able to achieve certain yields from their fabs. So I want to understand this from you. So when you make a chip fab, is it not a sure shot thing that if you have put all the machines in the right places, that it will be a successful plant? Does that mean that is there a chance that when we are maybe giving subsidies for the fab and setting up the fab, convincing global companies to come here and manufacture, so even after doing all that, is there a chance that a plant will not produce enough yield? And what does that mean?
It is likely. First thing is, may not happen though. I mean, we should not paint a pessimistic scenario that we are landing into some landmine or trouble, but it's possible.
And there is a mathematical probability.
Yeah, there is a probability. Actually, there is a possibility, and companies have to take care of multiple things. So, point is like this: the semiconductor manufacturing has become a most complex manufacturing process anywhere in the world. And many people don't realize, but here there are multiple elements. Those are important and instrumental. So you need the silicon, you need the materials, you need specialty gases, chemicals. There are at least 80 chemicals and gases we have mapped out. Those you need to produce the semiconductor wafer. And these are required at a purity level, which is like 99.99999. So they call 6 nines or 7 nines there. Now, India does not have it today, by the way. So India has got, I mean, we think chemicals, so India is a great industry, it is there, but they don't have the competency and the capability to produce to that purity level, including gases. Just an example, this one. So, but the point I was carrying out is, even for a semiconductor manufacturing, there are several ingredients. Those are utilized, and each stage of those materials, raw materials, and a process and running, the high degree of precision and a high degree of purity of those materials is very important. Anywhere a little bit things going wrong can impact your final yield and a final outcome. Yield is what? For example, you make a wafer, we call it the 8-inch circular wafer. You produce, let's say, 100 parts. Out of 100 parts, how many would be properly working part as per functions desired? That's what we call as a yield typically. So in many companies, those are really highly specialized. They would read about 95 to 98%. Somebody does 80%. And below particular yield, it becomes unviable, because then you are wasting. So if your yield is 80%, for example, that means out of 100 parts you are producing, 20 you have to throw. They are not working to the desired function, desired level. And this is where, for a newer technology innovations, this becomes very critical. Because you are doing your own process, you are developing your own technology and a manufacturing process for, let's say, somebody wanted to do 3 or 2 or 10, which Intel was doing, obviously, some other companies. So if everything is not perfectly working, you are not achieving perfection, it impacts the yield. Today, TSMC is a benchmark. They are best in class from Taiwan. Samsung is doing leading edge. Memory companies, for example, Micron or Hynix, they are doing. Now, coming to the lagging edge, the advantage with lagging edge I bring back now is these are mature process nodes. These are mature process technologies which have been perfected over the years, deployed over the years, and they are working. So when you set up the plants of these mature nodes, you are also taking a technology transfer from somebody, or somebody company is setting up their plants. They are at a position of advantage that there are very few uncertainties or variables that could go wrong, because things are already being deployed, perfected, and implemented. So that way, having said this, my view is there is a very limited chance, something can always go wrong, there is a limited chance that we will not achieve the desired yield, or our plants, those have been approved by central government MITI for Tata or Keynes and CG Power and Micron and other things, something would go wrong there. There's a very limited probability there. It's rare. I hope this works out for the reason I mentioned. These are already perfected, mature technology nodes. And obviously, one important thing remains there, which impacts the execution, is still there are many things which does not exist in India, particularly some of the materials, chemical gases I mentioned. So we have made already a report actually as a IESA and SEMI, which are the material gases required. We also started talking to these industry bodies and the industries as what are the component, other things are required over here, how to localize, including some global companies are coming up now. So there are several global chemical making companies are looking at setting up operations in India. So this is how the ecosystem is going to evolve. So there could be impact on a little bit timeline or execution. A rare possibility of something goes wrong and you don't get the right yield on a manufacturing output. But I'm fairly confident that things would fall in place eventually.
So many states today are trying to bring this, attract these electronics and semiconductor plants. Now we have seen in the last few years that there is this growing geopolitical fracture, right? You don't know when another war will start anywhere. Taiwan today faces a threat from China. I think a couple of weeks back, Israel took out some nuclear plants in Iran. Now, I want to understand, is there a want of strategic thinking even in the electronics and semiconductor industry that's coming up in India? Should we be concerned about a lot of these plants coming up in border states, that's in the northeast or on the western borders? Historically, we have had all the industrial development in the south. Is that safer in terms of if there is a war or a conflict with another country? Is that something that the industry thinks about?
I would say that we should not worry too much on that, considering some of the wars which broke out recently. Also, the warfares have become very advanced and they are able to make the impact thousands and thousands of kilometers actually, through air or through under the sea and whatever main cities, with the missiles or drones and other stuff. So if you are looking at a plant somewhere, it could impact. We should look at basically the overall ecosystem, how you develop and create, because typically manufacturing activity is different than the design activity. A design activity you can spread across anywhere in the country, and India has an advantage, it's a huge country, huge population, multiple states. What you need is the design tools and office setup and the manpower, talented people, and you are ready to go set up a design activity, and that is what is happening. So your design activity all across the country. Typically, manufacturing is created in the clusters, because for manufacturing activity, you need multiple raw materials and components and other ecosystem. So this ecosystem gets developed over a period of time. So my view is manufacturing, wherever we do, we need to look at more as a cluster approach or ecosystem approach. Today, what is happening is particularly electronics semiconductor. Every state wants the semiconductor to be done into their backyard. It's just like you ask the countries. Multiple countries are looking at how can I get the semiconductor manufacturing into my own country or electronics manufacturing into my own country. Similarly, many states are looking at today in a race that it should be in my state actually, considering the impact which I already explained previously. economic activity, job
But do
creations,
you
and all
see
those
it
things.
as a risk that, if there
Yeah.
is tomorrow a war with Pakistan or
No,
China,
I don't
on
see
the
as a risk.
border, they'll try to hit our economic manufacturing assets?
I don't see as a risk because even there are much bigger economic assets beyond that actually. You took the example of Gujarat. So semiconductor few fabs are coming there. Now Gujarat has got such a big industrial activity, including the petroleums and various other stuff it is there. If somebody has to hit, he will hit those things actually first before they hit the semiconductor manufacturing plant, which is housed in a small place in a building because you don't need a big space compared to the other industrial things. So I don't think that is the issue. If the country is protecting through its defense mechanisms, it will protect these plants as well. And the good thing about India is, and that's what is happening now, there are multiple industrial clusters, those are coming up. So for electronics, already there are 7 to 8 states, those are already doing manufacturing activities and they will continue to expand. So it's not located into single place. Same thing on a semiconductor side. I think we are on the call, so I cannot show you map, but I can tell you that in addition to Gujarat, there are semiconductor plants approved in Assam. There is a plant approved in Uttar Pradesh. There is a plant approved in Mumbai, a company called RRP. There is a plant approved in Surat by a textile manufacturer. There are a couple of plants approved by state government, by the way. One in Chhattisgarh, one in Odisha, there is one in Chennai, one in Bangalore. So it's already spread out actually. And around those plants, the rest of the ecosystem would come as a cluster, what we are referring actually over here. So I don't think we need to worry too much on the war-related activity and position our electronic semiconductor manufacturing at the center of India, not necessary over there.
Thank you so much, Ashok, for your time. It was a great conversation. I wish you all the best to take the ecosystem and the industry ahead, and hope to see you again soon on this podcast.
Thank you very much. It is a very nice conversation. And this is a very sought after sector. And today, electronic semiconductor is like a Bollywood movie. Everybody talks about it. So last year, I have counted, based on our survey, the semiconductor word is used in media 20,000 times. 3 years ago, it was mentioned 1,500 times. So you look at the amount of interest and a curiosity and a coverage it has generated, and thanks to the media people like you as well, those are really proliferating the importance of this sector and the technology. So thank you very much for the outlook.
Thank you so much, Ashok.
Thank you.